Find the partial fraction decomposition of the rational expression 5x minus 1 all over the quantity x minus 3 times the quantity x plus 4. So what we mean by that is this is our p of x in the numerator, and this is our q of x in the denominator. Because remember, we are looking at p of x over q of x. And so one of the things that you need to be aware of is this right here are non-repeated linear terms. Occasionally, when you have a problem like this, you may be given something that looks like this. Now, that looks quadratic. It is quadratic, but it is factorable, and in fact, it is factorable to x minus 3 quantity times x plus 4 quantity. So keep that in mind as you're looking at these. Sometimes you're going to have to simplify the initial problem before you can then start to pull it apart. So let me just get rid of this for the time being. And what we're going to do for step number 1 is go ahead and set up the partial fraction decomposition with our unknown constants on the right. So basically we just take this rational expression 5x minus 1 over the quantity x minus 3 times the quantity x plus 4, and we're going to set that equal to a over the first factor x minus 3 plus b over the second factor x plus 4. Now this is going to be similar to what I showed in the announcement, that we are basically taking the sum of two fractions and decomposing it into its component fractions. Now remember, I believe that I used something similar to this. 3 over 4 plus 5 over 7 is equal to, and then if you go ahead and multiply this out, you're going to have now, what I want to do is actually take this initial fraction and decompose it into its component sum of fractions. And that's what we're going to do. Now, with this problem, what I'm going to start with is taking a and multiplying it by the x plus 4. Then I'm going to add the x minus 3 times b. And notice that I no longer have a denominator. So I'm not worried about the denominator anymore. And in fact, I can simply write this as 5x minus 1 is equal to a times the quantity x plus 4 plus b times the quantity x minus 3. Multiply out a times x plus 4 and b times x minus 3, and we will end up with ax plus 4a plus bx minus 3b. Remembering that it's still equal to this 5x minus 1. And now what we're looking at is the fact that I have a variable term here, a linear variable term here, and a constant term. So what I want to do is add my like terms, and this is going to give me ax plus bx, and I'm going to factor the x out and end up with the quantity a plus b times x. Then we're going to add the constants together. And since they are like terms because a and b are defined as constants, I can just leave them simply as 4a minus 3b. And notice I'm going to offset it with parentheses right now, keeping in mind that it's 5x minus 1. And now what you'll notice is that I have the variable terms here, and those are equal to each other. And then I have the constant terms here, and they are equal to each other. And what I'm simply going to do is start with the coefficient of x and set that equal to the coefficient of x. So I have 5 is equal to a plus b. And then I can take my numeral 1 here, or negative 1 I should say, and set it equal to the other constants. And I have negative 1 is equal to 4a minus 3b. This is a system of equations. Remember, you are always going to be referring back to techniques and concepts that you have studied previously, so you have to stay sharp on all of these. So we simply want to solve this system of equations. Is equal to the quantity 5 minus b, and I'm going to insert it right here for a. And I'm going to end up with this other equation, negative 1 is equal to 4 times the quantity 5 minus b minus 3b. Now notice that I only have b's in this equation. So negative 1 is equal to 4 times 5 is 20. 4 times negative b is negative 4b minus 3b. I'm going to go ahead and quickly solve this. I'm going to subtract 20 from both sides. I'll end up with negative 21 is equal to negative 7b. Divide through by 7, or negative 7 I should say. And I now know that b is equal to a positive 3. But if b is equal to a positive 3, that means I can take this positive 3 and I can pop it right here in place of this b. And now I know that a is going to be equal to 5 minus 3, which is equal to 2. So now I have my solution. A equals 2, b is equal to 3, and I'm going to go back to my original. Let me scroll back up to my original expression, and I'm going to replace a with 2 and b with 3. So let's go back down here and let's go ahead and write it out as 5x minus 1 over the quantity x minus 3 times the quantity x plus 4. Remembering that I set it up as a over the first factor in the denominator plus b over the second factor in the denominator. And I know that a is equal to 2, so this is equal to 2 over x minus 3 plus 3 over x plus 4. And now, using this inside an integration, if I started out originally with the integral, and I'm just going to use a general integral here, I'm not going to make it a definite, it's indefinite. It'll be 5x minus 1 over the quantity x squared plus x minus 12 dx. Using my partial fraction decomposition, I can rewrite the integral as 2 over x minus 3 plus 3 over x plus 4. And then I can separate the integrand into two separate integrands. I can use a natural logarithm when I integrate this, and I've used a partial fraction decomposition of non-repeated linear terms.